This is the tutorial for the study guide for quiz 19. And so let's take a look at our first problem here. It says we're trying to graph this function, negative x squared plus 4. And so when I see that there's no bx terms, remember the quadratics go in this form, ax squared plus bx plus c. If there's no bx term, what that means is c is the vertex. So our vertex is 0, 4. And so I'm going to go up 4 spaces on my coordinate plane and put a dot there. And then I'm using the parent graph. It's negative x squared. And so what that tells me is if I go ahead and plug in some values, I don't have to worry about the positive 4. If I use the parent graph, I'm just going from the vertex. And so that negative sign in front of the x squared means negative 1 times by x squared, and then that's going to end up giving me my y values. So if I put in a plus or minus 1 in for x, I'm going to get the same number. I'm going to get 1 because when you square negative or square positive, that's what you get. But you end up getting negative 1 because I have to multiply by negative 1 at the end. So same thing with positive or negative 2. You're going to end up getting the opposite answer once you take this, or once you square those values, and because of that negative 1, so it's going to bring me down 4 spaces. So from the vertex over 1 space, that's what the x value tells me to do, left or right, and then you're going to go down 1. That's what we got when we've substituted in that 1 or negative 1. We got a negative 1. And again, it's due to symmetry, there's another point exactly on the opposite side. Over 2, down 4 spaces, and we have those points. So we can go ahead and sketch our parabola. That's what it'll look like. So on this one, same thing, no bx term, so this is the vertex. So my vertex is at 0, negative 4. So I'm starting down 4 spaces this time. And then I use the parent graph. This time it's a y equals 2x squared. So when you go ahead and plug in some numbers, you're doubling your x squared value. So that's what you're going to do in the y direction. So you plug in a positive or negative 1, you get 1. And then you have to double that, and that's why you get 2. So when you plug in a positive or negative 2, you see you square it, you get 4. But then you have to double that answer, and you get 8. So from the vertex over 1 space, and then up 2 spaces. From the vertex over 2 spaces, up 8 spaces. And again, symmetry allows us to put in the other points. And then we can go ahead and sketch our U-shaped graph, our parabola. So on the next one, again, we have the same situation. Negative 3 is our vertex. So my vertex is at 0, negative 3. And so I'm going to start down 3 spaces. Using the parent graph, it's a 1/2 x squared. So I'm going to pick the same x values, but I'm going to take half of the answer once I square it. And from the vertex, that's where I'll go. So positive or negative 1, you get 1 when you square those answers. Taking half of that answer gives you 1/2. So over 1 space only brings us up 1/2 of a space. Over 2 spaces, though, you see will end up giving us 4 for x squared, but then you got to take half of that, and that's why you only go up 2 spaces. Again, it's always from the vertex when you use the parent graph. I'll just do one more here just so you can see it. Half of 3 squared. So half of 9 is 4.5. So from the vertex, over 3 up 4.5 spaces. So you can see how these are definitely wider graphs as we take half or a fraction of a number. More narrow when you multiply by something bigger than 2, or the absolute value that's bigger than 2. Let's take a look at the next problem here. It says graph the function, label the axis of symmetry and the vertex. Alright, so what we need to do here, since we have an x squared term, we need to use the axis of symmetry formula. X equals negative b over 2a. So I go ahead and substitute that in. B is negative 4, so it's going to be the opposite of negative 4 over 2 times by 1. A is 1 out in front of the x squared term in this case. So opposite of negative makes a positive, and that makes 2. So you take that answer, you substitute into the formula. 2 squared minus 4 times by 2 plus 1. So you know you're doing something right if you have opposite signs of the ax squared and bx term, and one is double the other. So that way you know you can check you can check your work at least as you go. So I got negative 3 there, and my vertex would be 2, negative 3. So I start there. over 2 spaces, down 3, and then I use the parent graph. Just an x squared tells me to go over 1, up 1, over 2, up 4 spaces, because it's just a regular x squared. Once you get the y-intercept, check that. Make sure it matches your equation. Positive 1, that's right here. This is the y-intercept, and this is positive 1. It's the y-intercept because if you put x in, or 0 in for these x's, they'll cancel out. You're just left with y equals 1. So I know I did something right there. I do need to label the vertex, so I'll go ahead and put a vertex, or just a arrow showing what the vertex is, and the axis of symmetry. Axis of symmetry is just going to be a vertical line going right through the vertex, and then name that x equals, and this is 2, x equals 2. It's whatever you get for your negative b over 2a, and that's your axis of symmetry. So taking a look at the next one, I'll find the axis of symmetry first, negative b. So opposite of a negative 8 over 2 times negative 2. So that makes 8 over negative 4 makes negative 2 this time. So I substitute in. So negative 2 times by negative 2 squared minus 8 times by negative 2 minus 3. So we should always have opposite signs here. You see how this is going to be your positive 16 here. Positive 16, this should be negative, and it is, because 4 is what we get when we square negative 2. Times by negative 2 gives me negative 8. Again, opposite sign, one double the other if you take the absolute value of the negative. And that's the case. So I get 8, and then minus 3 gives me 5. So my vertex is negative 2 comma 5. So that's where I'm going to start. So over 2, up 5 spaces. And it's good I started up there because look at the parent graph. It's y equals 2x, negative 2x squared. So that means when you square 1, you get 1, but then you have to multiply by negative 2, brings us down 2 spaces. Over 2 spaces makes 4. Squaring 2 makes 4. Times by negative 2 gives us negative 8. And so that gives us some points to be able to plot. So I'll go ahead and sketch that in there, and just to check real quick, I've got a y-intercept. I see it's negative 3. Check to see if it matches right there. Y equals negative 3 for the y-intercept. So yes, I know I'm doing something right. So here's my vertex. So I'll go ahead and draw an arrow up to the vertex there, and I'll draw my axis of symmetry line down here. So this axis of symmetry is x equals negative 2 is what that is. So looking at this one, it says the height of a rocket after it is launched can be modeled by, well, here's the equation, where t is time in seconds. Find the maximum height and the time it takes to get there. So we're just doing the axis of symmetry, x equals negative b over 2a. This is going to give us time to max height. And so I know that because whenever we're trying to graph, the x-axis represents the independent variables, and time is independent, and my height is going to be dependent upon how long it's going in the air for. So height is going to be y, x is going to be time. And it even says that t squared represents time. See, it says where t is in time in seconds. And so this is the independent variable. We can plug anything in for t to get an output here. That's going to be our height. So time to max height, that's our x component. So it's just this, negative 3840 over, and then 2 times by negative 16. So we go ahead and do some work there. And when I go ahead and plug that in the calculator, this is what I get, 120 seconds. Seconds to reach maximum height. And then I want to find out what that maximum height is. So go ahead and plug it in. The y component, y coordinate of vertex is the max height. So let's go ahead and plug in. So we've got y equals, and then I've got negative 16 times 120 squared, and then I've got plus 3840 times by 120, and then plus the 2. And so you do some work there. Here I ended up getting negative 230,400. And then here, this should be double it, and it is. It's 460,800, and then plus the 2. So when I subtract these two, I end up getting 230,400 plus the 2, ends up giving me a total of 230,402. And that is in feet, is the maximum height, is the max height. So moving on to the last 3 problems, here we have some review problems, graphing different functions. So I have you graph these different functions to get us to remember that there are other types, and here is an exponential function. So if you forget, you can always go back to coming up with a little table, and that's what I would recommend if you don't remember what it looks like. Once you do it enough, then you'll remember, oh yes, I know what happens when I plug in a number. So I'm going to start with some negative numbers, and so if I started with negative 3, whenever I have a negative number in the x as the exponent, it's really the reciprocal of that. And so this is going to give me 3 to the negative third, and that's going to be 1 over 27. So a very small number. And so if I plug in a negative 2, it's going to end up being the reciprocal of that. So 3 to the negative second is going to give me 1 over 9, where negative 1 gives me the reciprocal of 3 to 1 over gives me the reciprocal of 3, which is 1 over 3. 0 is going to give me 1, and then I start going up. 3 to the first power, well, that gives me 3, and I could do 2 here. And 3 to the second power gives me 9. So I can't fit all these numbers in here, but I do see that as I go out to the left for negative numbers, the numbers are really close to the x-axis. So for negative 3, it's 1 over 27, almost touching that x-axis, but not quite. 1 over 9 is pretty close to it, but a little bit higher. 1/3 is going to be a little bit higher. And then I end up with, at 0, 1. At 1, I get 3. And then 2, I get 9. So it's going to be way up here somewhere. And so you can kind of see what this ends up looking like. It gets really close to the x-axis to the left, but then towards the right, it goes up very quickly. So that's what our line should look like. Make sure it doesn't cross the x-axis in this case. So on this one, well, it's just a linear equation. This is our y-intercept, and this is our slope. So I'm going to use that slope-intercept form, positive 3. Start up there, and then just down 1 over 2 to the right, down 1 to the right, or up and 2 to the left. And so we have a linear function here because x, or the exponent on x, is to the first power. Here we have an absolute value, and so we're going to end up with a piecewise graph here because it's going to change directions. And so if you don't remember what it looks like, then just set up a table, and that's always a good way to go. So we've got the absolute value of x, then we're going to take 3 away, find out what our y value is. Always start with some negative numbers, maybe like negative 2. Take that absolute value, get 2, take away 3 gives us negative 1. So if we have negative 1, you end up with a positive 1, and we take 3 away, and we end up getting negative 2. Well, you'll notice that positive 0, well, let's go on to 0 first. 0 minus 3 gives me negative 3. Notice that the positive number is going to give us the same value. So like a negative 1 gave us 1. Well, when we go ahead and plug in a positive 1 in for x, we're going to get the same exact number. Same thing with 2. So I see it starts down here, negative 3, and then if I go over 1 space to the right or left, you're going to end up going down 2 spaces. And so I've got points there, and then over 2 spaces, I'm going to end up going down 1 space. So I get the idea about what it looks like. So I'm assuming it ends up going like this, but since it's a perfect V shape. And so that's what the graph we end up coming up with there. So those are the types of problems you're going to end up seeing on this week's quiz. Good luck.